all made up of tubes and ducts and passageways of mostly cuboidal epithelium that does a really good job of making special substances and releasing that stuff into ducts. Now, I'm not going to make you memorize the names of all these different kinds of glandular epithelium. Instead, we'll do a more general kind of category. There are endocrine glands, which we're not going to learn about this semester. Endocrine glands, which is the first subject for A&P2, are special glands that make substances and they're released directly into the blood. So they circulate through your body, and every organ of your body is sensitive to them. So your sex glands, the ovary and testes, make sex hormones. They're released directly into the blood. So these are endocrine glands. They're cuboidal epithelium, but they're endocrine in nature. And that's a subject for another semester, so don't worry about this now. This semester, we're looking mostly at exocrine glands. Think of exit, door out. These are all glands where the glandular epithelium makes a product, right? And then the product is released out through a specific opening and it targets where it's going to go. So the pancreas, most of your digestive glands have a tube out, and they release their product right where the digested food is passing by. And as you can see by all of these exocrine glands, there's a wide variety of shapes and structures depending on the kind of material they make. I think a better way to categorize them might be by the kind of product they make. So among the exocrine glands, some are merocrine, I'm going to do an M for that. Some are apocrine, and some are holocrine. So merocrine glands, so here's a simple gland made of cuboidal epithelium. It's making all this substance, and it's releasing it through its duct. A merocrine gland very carefully releases just the substance it's going to make. So I like to remember merely merocrine, merely the substance. None of the gland itself breaks off and gets released, just the material. So your salivary glands, which make all these digestive materials, your pancreas, all the glands of your digestive tract are merocrine. They produce a clear, watery material that has no cells in it at all. It's just that material. On the exact opposite end of the scheme are the holocrine glands. And the holocrine glands make a material, and when the cell is full, the cell dies, sloughs off, and the whole cell comes out. So a holocrine product is cells and cellular debris and product all together. So you can have a thick, sludgy material that's filled with cell and cellular debris. The sebaceous glands, I think I spelled that wrong, but it's close enough because it's in your notes. The sebaceous glands are holocrine glands. These are the glands that you find surrounding every hair follicle, whether it has a hair in it anymore or not. The sebaceous glands produce this thick, oily sebum that's designed to lubricate your hair and lubricate your skin. These are the glands that act up so much in teenagerhood, produce excess material, the duct gets plugged, the material builds up, bacteria act on it, and you get an inflamed, infected spot called a pimple. But the material is really important because under normal circumstances, sebum is the thing that keeps your skin from drying out. Yeah.
That's a holocrine gland.
I'm sorry, holocrine.
Yeah, okay. I'm just making sure
I'm
it's the same
sorry,
thing.
you sometimes have to correct me because my brain is not engaged to my mouth.
It's okay.
So
Same.
yeah, this holocrine product is a thick, dense sludgy stuff. Bacteria do like to eat it, so there can be problems with it, but it's critical because it keeps the skin moist and pliant. And as we talk about aging of the integument, you will notice that the elderly don't have good active Holcomb glands anymore, so the skin gets very dry, and because it gets dry, it's wrinkly and it cracks and fissures and bleeds and gets infections.
Mhm.
This Holocrine product, this sebum, also is an antibacterial. So you will hear people say, don't wash your skin too much, because the material not only lubricates, and it also acts as an antibacterial aid. Yeah.
Why does bacteria then like to,
Because it's full of juicy cells, yum, 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 yum.
oh, it's eating the cells, not the
They eat the
sebum.
cells, but they also like the oil, lots of calories. Whereas sweat, which is an American product, doesn't have anything edible in it. It's water and salts. So it's not as attractive a food source for bacteria. But certainly the Holocrine products like sebum are really inviting to bacteria.
Right, so I'm confused, why is it both an antibiotic and?
Because it contains a wide variety of substances, not just oil, some of these mild acids, and then when the normal resident bacteria act on it, it makes it even a little bit more acid. It also contains antibody-like materials. This is very interesting. So it's a protective material. Now, apocrine glands in the middle, there's a lot of debate about what's in, whether we have apocrine glands or not. And I think last time your textbook said, yeah, we do. And the mammary gland is a good example of it. I don't know what to say. Just remember, for my purposes, right now we think that mammary glands that make milk are apocrine glands. And apocrine, I remember by apocrine means a piece of the cell. So you get the product along with just a little bit of the cell, not the whole cell, but a bit of the cell. So this is a little bit thick, because not only does it contain oils and fats and carbohydrates and protein, all those cellular products, but there's a little bit of cellular ring too, in something like milk, mammary gland milk. It contains antibodies, milk is full of all sorts of substances made by the cell itself, including the normal cell components. It's a very nutritious and protected material. All right, now we're ready to move on to our next category of tissues. I'll just orient you to the idea of connective tissues today. And some of the big ideas here. So connective tissues collectively add, support, transport, and connect. But they vary quite a bit in shape and texture, depending on the very particular job that they need to do. So let's make a few generalizations about them. In general, not in every case, but in general, they can undergo mitosis. So there's good repair. So blood is a connective tissue. Bone is a connective tissue. Bone is a connective tissue. So is tendon and ligament, right? They're all connective tissues. And they all can undergo mitosis. So when you injure them, they should repair. Now, a few in that category, as we'll learn later on, don't repair very well. And it's not because they can't do mitosis, it's because they don't have a good blood supply. But if you have a good blood supply, all the connective tissue types, bone, blood, tendon, ligament, fat. Let me give you some examples so you know. Fat, bone, blood, tendon, ligament, cartilage. They're all connective tissues. Blood is always astonishing to people that it's a connective tissue, but it is. It's a liquid connective tissue. And collectively,